It's 5 o'clock on Tuesday, which means it's time for math. My name is Jeremy Jasper with KathleenJasper.com. And just like we do every Tuesday from 5 to 6 p.m., all things math for your teacher certification exams. So welcome again on another session where we have 10 problems that we're going to go through. This is an informal math session where a lot of it is based upon you and the problems that you have for your math exams. We got a lot of requests in the past week for a bunch of problems, so I appreciate that. That helps me have an understanding of what it is that you're looking for. And so tonight we have 10 problems that were all selected or sent in by you, and that's what we're going to cover for tonight. So just like we do every Tuesday night, I'll go through 10 problems. Make sure that you have your calculator handy. And if you haven't done so already, there is a link below, whether you're watching on YouTube or on Facebook. And that is where you will get the 10 problems that I'll be going through tonight. Each of those 10 problems is printed on its own slide so that you have your own scratch paper to work with. Because along with the calculator, you've got to be able to work the scratch paper because that's all you're going to be able to use on your exam. Okay, so those of you that work on math books or study guides, or you've got that problem right in front of you in the paper and you're working with your head down, you've got to practice looking at a screen with the problem on it and then transcribing whatever it is you need on scratch paper, because that's how you're going to have to do it during the test. Okay, so let me go ahead and make sure everybody is live and online, and you can go ahead and get anything that you need situated, and we will go ahead and get started. I'm going to go ahead and put the first problem on the screen, and then we're going to go from there. So let me just check. The problems tonight are going to range from like an elementary level to a general knowledge, Praxis Core type of a level, just so you have an understanding and an idea of what it is that we're going to be covering today. Now, some of the stuff you may not be or may not necessarily need, but I assure you, just going through the math, understanding the math, even, towards the ends of the problem is usually where just the basic arithmetic is, and just understanding that and focusing on that, that's going to help you a lot as well. Okay, let me just check one more channel. Everybody's good on Facebook. If you have any comments whatsoever, go ahead and just, as I'm going through it, go ahead and comment. I will try my best to catch them in real time, but I will definitely, usually by problem 5, if I forget to look back, I will double check to make sure everybody that has a question will get that question answered. Okay. All right. So it looks like everybody is on and we are good to go. So let's go ahead and do this. This first problem here, I actually got a lot of problems that are similar to this. So this is something that's assessed a lot, where they give you, it says, given the following information, what is the equation of the line? So an equation of a line is going to be heavily assessed on pretty much any math assessment. And they just want you to understand, based off of information, off of data, can you create the equation of a line? So real quick, let's just go over the basics. You may be familiar with this, and if you're not, I'm just going to be honest with you, you need to get familiar with this. This is called the slope-intercept form of a line, where this letter M here is for slope, and this letter B here represents the y-intercept. So when we're dealing with a chart like this, okay, the slope, and I know it's going to sound kind of funny, but the way that I teach this, I kind of teach this to the point where I'm just trying to get you to understand enough to get the answer right. Try and show you whatever tips and tricks that I have so that you'll be able to do so. And when you're dealing with charts like this, the slope, okay, is really I'm gonna try and do it. And my handwriting's always sloppy the first couple problems, so bear with me, but you get the idea. The slope is the pattern of y. Now, what do I mean by that? If you take all these numbers here, there's going to be a pattern. And that pattern is either going to be, it's going up by so many or it's going down by so many. That's the whole point of having a linear function, right? Linear, it goes in a line, whether it goes up, whether it goes down. It's based upon, the pattern, rise over run. So without getting too much in the weeds, just think of the pattern of the y. And then the y-intercept is always going to be your coordinate. It's an actual coordinate. It's going to be 0 on the x, right? Because it's just 0. And then whatever your y value is. So knowing all of this, how can we put that information together to get our equation? So the first thing that we can do, usually y-intercept is the easiest one because you're looking for this y x equals 0. But you'll notice this is only going to the lowest number 1. So we're going to hold off on that because there's no 0. If I were to drag this out further, right, if I were to make more slots, then if I count here, this would be 0, this would be -1. I need to figure out what that number is in order to find my y-intercept. But we're going to hold off on that because it's not readily available. So now I'm going to go to my slope. Now, when I say the pattern of y, look at 4 and look at 7. As long as, and this is important too, see how this goes from 1 to 2, 2 to 3, 3 to 4, 4 to 5. It goes consecutively. Sometimes you'll see it where it goes from 1, 3, 8, 22. You got to be careful with those, okay? So as long as your x is going consecutively, like it is here, then we can figure out the pattern between these. So from 4 to 7, we know that it's a pattern, it goes +3. From 7 to 10, +3, +3, +3. Get the idea? It's +3. It will, all linear functions will have a common, I call this pattern, but essentially it's the slope. The slope is 3, and it has to be the same number. If it's not the same number, then it's not a linear function. Okay. So now that I found this, and I call this the pattern of y, just because that's how I, in my head, can see that instead of just calling it slope, because a lot of you may not understand what slope is. You didn't learn it. You don't need to learn it. You don't need to know it because you're probably teaching art or Spanish or even science, whatever. It doesn't matter. So in my mind, I see pattern of y, it's +3. So that means I will take this m out and now put the number 3, okay? Slope is 3. Go to your answer choices. Which one of these has a slope of 3? Well, it's not A because there's nothing there. B, C, D all have it. E has a 4. That's not right. Okay, so we're good there. We've eliminated 2 out of the 5, right? So now you went from a 20% chance of guessing this right to a 33% chance of guessing it right. Make sense? So now we need to find this slope intercept. If I need to find this x at 0, where it is here, would you agree that if I went from this 4 and now this is still, the pattern is still 3, but I'm going backwards now. So that means I need to subtract 3 because from this number +3 is 4. So what number +3 equals 4? And that's going to give us the number 1. Does that make sense? Because 1 + 3 is 4. And then the pattern continues. I know that my y-intercept, because x at 0 is always my y-intercept, is 1. So I can go ahead and take that b out of there. I can put the number 1. And when I look, the only answer choice that has the equation 3x + 1 is answer choice B. Okay, so that is my way of doing this. All right. I just feel like it's easier. Now, I'm not telling you to do it this way. There's other ways of doing it. And I can go ahead and I can show you real quick. And it's more along the lines of what your math teacher may show you, but I'm telling you, I show you this way first because I think it's easier. So the other way that a lot of people are shown how to do this is you got to do the whole thing where in order to find slope and you're given this information, then we're going to go ahead and take our 2 points, right? We'll just take the easiest numbers that we can. So 1,4 and 2,7, right? So the way that I find slope is I take the two values and I stack them on top of each other. So let's do 2,7 like that, and we'll subtract them. So 1 minus 2 is going to be, and again, this is something that I tell everybody a lot. You may know 1 minus 2 in your head, okay? And, you know, you put it down, it's -1, right? Just -1, but you have a calculator. Don't, you know, when you're taking the test, you're stressed out, you're nervous, you're anxious, you're all these things. These types of small little problems can throw you for a loop, and you've got to be careful. So even if you have to just check yourself with the calculator just to make sure, that's fine. Nobody's ever going to make fun of you for using a calculator on this test, I promise you. And then 4 minus 7 is going to be -3. Okay. So now we know that our slope, which is m, if I can write the letter m, slope is the difference of y over x. So now, you know, our points are written as x comma y. So take this -3 over -1, and you have m is equal to negative divided by negative is a positive is 3. So now you can have a slope of 3. You can check your answer choices, do everything that's not 3, cancel it out. And then now you need to figure out what your y-intercept is. So go ahead, erase all this. I have a slope of 3. Now you can take a point. So let's go ahead and take this point here, 1,4, put it in for your equation of a line. So you can see already how this can be confusing. And then 1 is x. 1 is x, 4 is y, x, y. As we put that in, 4 is equal to, and we know that x is 1, our slope is 3 plus b, right? Got to find what b is. That's what we're missing. So 4 equals 3 plus b minus 3 minus 3. 1 is equal to b. We'll put that back in, right? B represents that number there, and that's how you figure out your equation of a line. Okay, 2 different ways of doing it. I like the other way because I can just look at the chart and I can already tell, find the pattern, and then go from there. But if you don't like that way, if you like going it the way that like your math teacher may teach you, then this is the way to do it. Okay. All right, problem number 2. An online music streaming app charges 10 cents per download. The app also charges a flat fee of $8 per month. If your monthly bill totaled $12.50, how many songs did you download this month? So again, you'll see the focus on these problems is your linear function. This time they don't necessarily tell you it's a linear function, but that's essentially what these problems are all about. So as you read this, I kind of want you to put it together. So I've got 10 cents per download. Okay, what am I going to do with that 10 cents? So I know I've got 10 cents somewhere, and it says per download. The app also charges a flat fee of $8 per month. Well, I've got a plus 8 somewhere here. If your monthly bill totaled $12.50, how many songs did you download? Well, if I take my songs And then I also take my fee. So it's 10 cents per song, $8 per fee. If I don't know what the song is, or I don't know how many songs I have, because it's per download, that's where my variable goes. And then all of this is set equal to, and I'll show you why I'm writing it this way, $12.50. You could also do $12.50 here. But the only reason why I say this is because if you ever see this type of problem, this is the pattern where you're charged something for a certain amount. So whether it's your downloads or you've got a gym membership and it's months, or anything in that nature, you're essentially doing what we just did in the problem before. You're finding the equation of the line. So at $12.50, I've got 10 cents per download plus my $8 fee. This $8 fee never changes. Whether you have 1 song, 0 songs, or a million songs, you're always paying that $8 fee, right? And that's it. That's the one-time fee. Everything else is based off of the month. So here we go. Figure out what X is. So subtract 8, subtract 8. I now have 450 is equal to 0.10x divided by 10 cents. And you will see that our X is equal to 45. Okay. It's simple once you get the equation. The problem with a lot of people is just getting to that point of having an equation. Okay. And so what we need to do is just understand what type of problem we're getting, and then say to ourselves, okay, I remember this. I'm supposed to put it in the equation of the line. How do I do that? Okay. And it's in this form. So once you get that down, put the right values in the right spot, then you're good to go. Okay. All right. All right. A comment coming in. Yeah, we only do math on this live feed. So our Tuesday sessions are only for math. There's going to be no science on this one. All right, problem number 3. Diagram above represents a circular garden where the straight path from point A to point B goes through the center of the circle. The circumference of the circular garden is 120 yards. Approximately how long is the path from A to B in yards? Now, some of these problems can be a little confusing if you're not comfortable with circles and the terms used for circles. You have a lot of words on the screen, and then you got a picture of the circle, and there's no values anywhere except for this 120 right here. Okay. So a lot of the times these questions are built to essentially be overwhelming, I would say. But just remember, depending on the test that you're taking, and this is important, figure out how much time you have per problem. So they will give you they'll give you how many problems you have and the amount of time that you have while you're doing in your test blueprint. And so just figure out, divide the time by how many problems, and then you'll figure out what you'll have. So understand that you've got probably maximum 2.5 minutes on some tests. You got like 2 to 2.5 minutes per problem. All of these problems are designed to be solved in that amount of time. So if you feel yourself going longer than 2, 3, 4 minutes, then something's up. You got to figure out what's going on, and you got to kind of look at it from a perspective of, I know I can solve this a lot quicker. So what do I need to look at? So something like this, it's looking for, it's giving you circumference, and it just wants to know how long the path, what's A to B. Okay. So I know if I go from one point to the circle through the center to another point on the circle, that's called the diameter. Okay. So when it asks me how long is the path from A to B, I need to find diameter. If I'm dealing with circumference, circumference is the same as diameter pi, or 2 times pi times radius. All right. Since I need to find diameter. There we go. Since I need to find diameter, I'm going to use this formula here. They gave me the 120 yards as circumference. So 120 is equal to diameter times pi. It says approximately. Watch out for words like approximately or as close to or, estimate, because you don't need an exact answer. It's how I call it in the ballpark. So because you can't, some people don't have the pi button on their calculator, then just go ahead and it says approximately. Well, pi is approximately 3.14. So now I have 2 out of the 3 values. So as long as I have 2 out of 3 values, I can always find the third. So let's just divide 3.14, divide 3.14, and I get 38. So diameter is equal to 38.2, roughly. Well, the only one that is anywhere near 38 is, or 38.2 is 38. So B is going to be our answer. That was a real quick problem because finding circumference is kind of easy. It's just either diameter pi or 2 times pi times radius. And as long as they gave us what our circumference was, we're able to find any of those values. Okay, so that's it. Don't get overwhelmed sometimes when you see these types of problems. All right. Next problem, number 4. Are we on number 4? Yeah. Okay. In a sequence of numbers, the first term is x, and each term thereafter is twice the previous term. The fifth term is 160. What is the value of x? Okay, so patterns. You'll see a lot of patterns on your math tests. Sometimes there's fancy equations for your patterns, but we don't always memorize those, or we don't always know which ones to use. It gets confusing sometimes. So instead of trying to figure out and memorize different formulas for different types of patterns and sequences and all this kind of stuff, just kind of read the problem and follow it for what it says. In a sequence of numbers, the first term is x. So I know I have this term x. And then each term thereafter is twice the previous term. And they want the fifth term. So we got to extrapolate this out to 5 terms. So I have x here. I'm supposed to do times 2. So x times 2 for, it's times 2 the previous. So then take the previous again, x times 2, and multiply that times 2. Okay. And then take the previous, sorry, I don't have enough room. So the previous is x to 2, and then multiply that by 2. So that's our 4th term. And then finally take the 5th term, which is the 4th term, x 2, and then add another 2 to it. So this is our 1st, 2nd, 3rd, 4th, and 5th. And if it says the 5th term is equal to 160, well, that's this one right here. Okay. So that shows me that I have the pattern right. So it's x and 4 2s. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is going to be 16x is equal to 160. That seems pretty easy because when I do that, I get x is equal to 10. And so I look at the answer choices and I see 10 is there. And if you want to go ahead and just double check yourself, all right, let's go ahead and put 10 in as our new variable. Be able to do that a little better. So it says start with 10 and then take that and multiply that by 2. That's going to be 20. And then 20 times 2 is 40, times 2 is 80, times 2 is 160. And that's what we need. So that's it. Not too bad, but just follow the pattern And that's it. Okay, problem 5. A local government spent 82% of the $12,500 budget for snow removal. How much of the budgeted money for snow removal was not spent? Okay, dealing with percents, there's a couple ways of doing them. And honestly, each way it can probably take you about the same time. It's just a matter of how much you have to write, or just the approach at which you need to solve it. So if they spent 82% and we want to know what was not spent, that's important. Make sure you read the problem correctly. The way that I look at any problem dealing with a percentage, whether it's giving you a percent discount or it's adding a percent like a tax, or just anything dealing with a percent, I always take whatever value they give us as 100%, right? Does that make sense? 100% of the value of this problem should be associated with this 12,500. Okay. So what I have here is got 82% was for snow removal, which means the rest of it was not spent. So if I do 100% minus 82%, I get 18%. So that would make sense if I did 18% of our value, that would give me the amount that wasn't spent. So take your 18%. How do we figure out percent to a decimal? You can do it a couple of different ways. You can put the decimal point at the end here, and it always goes 1, 2 to the left. So you're left with 0.18. Okay. Or if you can't remember that, you can always do 18 divided by 100, because the word percent means per 100. So it's this number for every 100 that you have. 18 divided by 100 is 0.18. We multiply that by 12,500, and you will see that we get $2,250. So the amount of money that wasn't spent represents 18% of that budget, which is $2,250, and that is D. Okay. The other way, the more common way that I see people do it is you go ahead and again, we're going to find the same exact answer. Okay. Just a couple different ways of doing it, and that's totally fine. So a lot of people will take the 0.82 times 12,500. And what this does is that gives us the value of 82%, because that's what they give you. So 0.82 times 12,500 is equal to 10,250. Now take your original, which was 12,500, and subtract 10,250, and you end up with 2250. Same exact thing. Okay. Except the other way, where I do the 18%, it does it all in one step. You have to do 2 steps for this one. Is that going to make a big difference? I don't know. Maybe it will, probably not. I don't know, but you have to understand seconds count. So if you keep writing different steps, that takes seconds. Say you've got a 60 question test, and you can save two seconds on each problem. Well, that's 2 extra minutes that you have on that test. Okay. So again, for most of you that are having difficulties passing your math exams, timing is probably the most common, the common thing that you have an issue with in getting you to pass the test, because you just run out of time. You can probably do it if you had all the time in the world, and you can probably figure it out, but that timing is what's really, really killing a lot of people. Okay. Problem 6. So this one was sent in. I don't know where I would kind of put this. It kind of falls in the middle, but it's an interesting problem. And so I just want to make sure that you understand how to do it, okay? So what we have is if the value of x plus 3 over 2 squared equals 49 over 4, which of the following could be the value of x? So the way we want to figure this out is the first thing I did is I said, okay, I've got this value here and it's squared. So let me kind of bring that out. So if we have to, distribute this out, this squared, because it's x plus, is really x plus 3 over 2, x plus 3 over 2, and then equals 49 over 4. So I did that, and I thought to myself, oof, I said, I'm going to get a quadratic equation here. I'm going to get some x squared, and it's just an x, and it's going to be a lot. And I think to myself, this is not the type of problem that I would get on a general test like this. So just kind of erase it and think back, all right, how can I solve this in a fairly quick manner without doing all that, finding roots and all that kind of stuff? So I rewrote it. I've got x plus 3 over 2 squared equals 49 over 4. I saw this, I was like, 49 over 4, that's an interesting way of putting a fraction. But I did realize, since I'm dealing with a square here, and I've got these 49 and 4 are perfect roots, square roots. So in order to get rid of a square, you take the square root, and whatever you do to one side, you do to the other. So this and this cancel out. So now I've broken the x plus 3 over 2 out of the parentheses and the square. And I've also done 49. So let's just take this. When I square root this, it's the same as saying 49 square root over 4 square root, which is going to be 7 over 4. Okay. So now let's solve for x. Okay. So if I do subtract 3 over 2, subtract 3 over 2, I will get, oh, I forgot that said 2. Cancel out. This is going to turn into a 4, which means this is going to turn into a, what did I do here? Oh, I'm sorry. I knew that looked weird. Sorry about that. I did exactly what I didn't want you to do. I did the 49 square root, and then 4 square root is 2. Oof, sorry about that. So now I get x is equal to, and then 7 minus 3 is going to be 4, and then that's over 2, which is equal to 2, which is equal to 2. And there you go. I get 2 as my answer. And I look up here and I say to myself, uh-oh, why is there no positive 2 there? So don't make this mistake. Don't just say, oh, I must have done something wrong. I see 2, but it's negative 2. Circle the negative 2, and then off you go. Okay. Because you got to be confident with what you solved. And we did everything right and we got a positive 2, but it can't be that negative 2. So what in the world is going on here? And here is what needs to be understood. Okay. So with this 2, I need to get the value that's inside of the parentheses. What's happening, and what you need to see here, is that this x plus 3 over 2 and then squared, this is what is important, because this value here, this can be a negative value, because what is a negative number times a negative number? It's going to be a positive number. Okay. So how can I get this? This can be a 2, right? But then it can also be something else because it's being squared. I hope that makes sense. So this is going to be some type of negative number. And that's how you have to see it with the square roots. Real quick, just so you understand, what if I had, you know, whatever this is, say this is x, right, squared, and it has to equal 4. Well, x can equal, what happens when, what if I have x equal 2? So x times 2, or 2 times 2 is 4. What happens if I have negative 2? Negative 2 times negative 2 is also 4. That's what I'm trying to explain here, that you can have two different values when you square something. It can be a positive value, it can also be a negative value. In this case, it happens to be the same, where it's 2 to get 4. So let's figure out what we need, what our value needs to be in order for us to get this x is equal to our 2. So the way that I have this here, when I have this value, x plus 3 over 2, and I make it with the 2, so I'll do 2 plus 3 over 2. To make it easier, let's call this 1.5, right? 3 over 2. If you do 3 over 2 in your calculator, you're going to get 2 plus 1.5. And 2 plus 1.5 is going to give me 3.5. So this right here, this value has to equal 3.5 or negative 3.5. Okay. So that's what we're going with here, because that's how it has to be. So in order to figure that out, we need to set it equal to our x. I'm just taking that again, x plus 1.5 equals negative 3.5. Okay. So then subtract 1.5 minus 1.5, x is equal to negative 5. Negative 5 is the answer to this problem, because when I put negative 5 in for that x, I get this negative 3.5. And then when I square it, negative 3.5 times negative 3.5 gives me a positive value. Okay, I hope that made sense. And if you ever get a problem like this, which you may or may not, this was sent in from somebody, so I don't know if they got it or not, but that's what you have to look for when you get this squared value on the outside. Okay. All right, moving right along. Let me just double check and make sure everybody is doing okay on our other. I got the YouTube up. Let's make sure Facebook's got no. Oh, okay. Okay. It's looking like somebody's asking the amount of problems to figure out you need, right? Okay. If you go ahead and you were to search your test, so whatever test you're taking, let's just say Praxis Core Math. If you say Praxis Core Math passing score, it may pull up a some type of passing percentages. If you take the Florida exam, I know there's one for that one. And usually the passing score for any math is going to be between 73 and 75%. That's what we tell everybody, to focus on getting 73 to 75% of your questions right. And the reason why is because the pass is usually from 68 to 73%. So if you practice getting 80% of your questions right all the time, then you really shouldn't have an issue. But they'll never tell you what the exact percentage is for the amount that you need right, but it really hovers around 73 to 75%. So that's going to be the answer to your question there. All right, problem number 7. In the sequence of numbers 2, 6, 38, and 1,446, which of the following is true? So you'll get a lot of these types of problems where the problem is really the answer choices. You got to go through and you got to figure out whether or not the answer choices are correct. Okay. You can't, most of the time, you can't figure out what the problem is just by reading the actual, the problem. So we'll start with this first one here, knowing that we're focusing on these numbers here. The first two numbers are 2 and 6, which is correct. And each successive number, that means each number after, is found by multiplying the previous number by 3. Well, I see that 2 times 3 is 6. That works. And then 6 times 3 is 18. Well, that doesn't work because it's 38. So A is out. Okay. And so that's all you're doing. You're just trying to just scribble out what each answer choice means, right, on your scratch paper or in your head, so that you can either choose the correct one or just eliminate the bad one. Next one says the first number is 2, which is correct. And each successive number is found by subtracting 2 from the square of the previous number. Okay, so 2, and then I've got 6. So subtracting 2 from the square of the previous number. So that's going to be 2 squared and then minus 2. And so that's 4 minus 2, which is 2. Well, that does not work for the first one. So therefore, it's not going to work for all of them. Okay. So that's out. Okay, what's the next one? We have the first number is 2, and each successive number is found by adding 2 to the square of the previous number. So when we do that, I've got 6 here. So that means it's 2 squared. Let's do this. I've got 2 squared, which is 4 plus 2, which equals 6. Okay, that works. And then I've got the next one is 6, or the next one is 38. So I do 6 squared, which is 36, plus 2, which is 38. Okay, that works. And then the next one would be 38 squared, which you got to do the calculator, which you can probably guess that we might be onto something here. And when we do our 38 squared is 1444 minus 2 is 14, I'm sorry, plus 2, 1446. So it's looking like C is the correct answer because everything works out. If I look at D, the first two numbers are 2 and 6, and each successive number is found by multiplying the previous number by 2. Well, that doesn't work because 2 times 2 is 4 and 6 times 2 is, and that just, it's not no go. Okay, so that's out, and C is the correct answer there. Okay. All right. Question 8. In the XY plane, point A has coordinates 1, 3, and point B has coordinates 7, 3. Which of the following could be the coordinates for point C so that the area of triangle ABC is equal to 24 square units? Okay, so depending on what math you're taking and you get this type of problem, they're talking about the coordinate plane. And so let's just go ahead and just draw a rough idea of what they're talking about, because it's always easier to deal with a picture. So here is our coordinate plane. Actually, I want to do this. I want to make sure we're. So I have point A at 1, 3. So here's 1, and here's 1, 2, 3. So point A is right here at 1, 3. And then point B is at 7, 3. So it's 1, 2, 3, 4, 5, 6, 7. And then it's still at 3. So what I have now is I'm going to connect these 2 points because that's going to be one side of my triangle. I can find the value of this line because it's from 1 to 7, which gives me a distance of 6. Okay. So now here's where this part comes in. I am going to have a triangle. This triangle may be from here to here, right? That's one possibility. The triangle can be from here to here, okay? The triangle can also be from here to here, And the triangle can also be, oh, let's do black, from here to here. Okay. Does that make sense? I know that's a lot of different colors and a lot of crazy ways, but with that line being from A to B, I have the possibility of having 4 different triangles. And I'm just going to tell you, they're going to be right triangles because that's the only way you're going to be able to find the area easily for a problem on a certification exam for math. So which one of these is going to be our point? So if you look, and I know I would do this first, and then I would look at the points, and I would kind of just go through the points. If I got 1,7, so if I go 1 over and 7 up, right? 7's going to be in this area here. So 1,7, that's going to be answer choice A. 1,8, that's going to be answer choice B. 7,11, so I got 7 and then comma 11, that's like way up here. That's going to be C, and 7,8, that's going to be D, way up here. So I can eliminate, right? Because there's no negatives here. So it's either one or the other. It's going to be this left one or it's going to be this right one. And the way that we're going to figure this out is by doing a little bit of math. So how do we find the area of a triangle? The area of triangle is found by doing 1/2 base times height. Okay. Well, if I know that our triangle is 24, and that's equal to 1/2, we'll just turn 1/2 into 0.5 because that makes things easier, with a base of 6. Okay. And I know it's got to be 24. So I got to find what my height is. So I've got 24 is equal to 0.5 times 6 is going to be 3. And then my height. So then divide, let's do over here, 24 divided by 3 is going to give me a height of 8. So what that means is this: from here to here, I need to find 8, or from here to here, I need to find 8. So how am I going to find 8 on either one of these sides? Well, these X's all start at 3. Okay. So let me erase this so I can clean this up. I think we're okay. So how do I get this 8, right? If I know that my starting point is 3 and I need to get 8, so what I'll do is I'm going to do, I'll do whatever value we have minus 8. No, let's do this. I'm sorry. I'm thinking 2 different ways here. Three, yeah, let's just do that. 3 plus 8. Sorry, I've got 3. So 3 plus 8 is going to equal 11. All that means is our Y value, right? Here's 3. That means that's 4, 5, 6, 7, 8, 9, 10, 11. So which one is 11? And you can see that it's going to be C, because from here to here, like this is going to be 11. So our triangle is going to be this right here. Okay. You got to find out that this is 6, and you have to find out that this is 8. And if I put a coordinate here, okay, and I add 8 to it, and I'm starting at 3. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 11. Okay. So 7, 11, 7, 11 is going to be our our triangle that will figure out our answer, because I'll do 7 over and then 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'll go over right here, 7 comma 11 triangle, and there you go. Okay. All right. Okay, problem 9. What is the greatest common factor of 56, 112, and 560? So let's do a quick refresher on greatest common factor. Greatest common factor means the number that all three of these numbers have in common as a multiple. All right. So it means, can I take some number? So if they're both even, right? If they're all even, not both, all three, if all three are even, that means two is a factor. I might have said multiplier, greatest common factor. So 2 is a factor. 2 is the smallest factor because it's the smallest one out of all three of them, but you can do 2 times a number and get 56, 2 times a number, get 112, 2 times a number, get 560. Well, what we want to find out is the largest number that we can multiply other numbers to and get 56, 112, and 560. It's the one that they all have in common. Here is a foolproof way of finding greatest common factor. The very first thing you do is you take the smallest of the three. In this case, take the smallest of the three numbers and then divide it by all of them. Because you cannot have a factor for all three of these greater than 56, right? That can't make sense because you can't have a fraction. You can't multiply a number greater than 56 and get 56 unless it is less than 1, right? That's a fraction. So take the largest, and that's how you start out. So take the smallest of all the numbers and divide it. So, I mean, we know 56 goes into 56. 112 goes into 56 2 times, and 560 goes into 56 10 times. See how all these, here's 1. See how all these are whole numbers? 56 times 1, 56 times 2, 56 times 10. 56 is a common factor, and it happens to be the greatest common factor because that's the biggest one that there is. So that's how that works. Don't overthink these. We think about greatest common factor, and then what we have to do is a lot of people will take this and they'll start doing their trees, right? So you get 2 and 28, and then you do 2 and then 7 and 4, and then you start doing all this kind of craziness, okay? And then you'll find out that they all have a 2, a 7, and a 2. Well, this should be 2 and 2, 2 and 7, right? Don't go through all that. Greatest common factor is easy. The smallest of the three and divide it. And then go through your answer choices. It can't be 112 because that's too big. And if it wasn't 56, now try 24 and try 16. Don't try making your little factor trees because it's a multiple choice test. You already have possible answer choices there already. And there you go. Okay. All right. And now the last one. The Brown family is headed to Tallahassee for a football game. They want to figure out how long the trip will take them. They will travel at an average rate of 75 miles per hour. They have to travel 650 miles. What equation would help them determine how many hours it will take them to reach Tallahassee? So we don't need to solve it because if we look at our answer choices, we're given equations. So we have to figure out which one is correct. They give us distance, they give us rate, and they want to know time. So this is a perfect opportunity to cover. You'll see it at your D equals R times T. But what I want to show you is this. I call it the DRT triangle. And some of you have seen me do this already. It's very popular. I find it super easy and super efficient when we're solving these types of problems. So what I use this triangle for is to add in all of the values. Distance is going to be 650. So what you do is you just, well, let's do this so you can see it. So we'll have D, R, T. So in this case, D is going to represent 650. And then I have 75 miles per hour. 75 miles per hour is rate. So 75 is going to go in this section of the triangle. And it asks how many hours or time. So I don't have time. So that's going to be my variable. I want you to now look at the values. Where are the two values? Because you always need 2 out of the 3 values. In this case, I'm going to, because I don't have time, I'm going to erase it. Look at the 650 and the 75. So the 650 is on top. 650 is on top. 75 is on bottom. Now I know if I do 650 divided by 75, I will get the amount of time it takes to go on this trip to Tallahassee. And that's it. I don't need to solve it. Okay. And if I look at the answer choices, A isn't correct because it's got 75 equals X over 65, and that's not going to work, even if I manipulate the problem around. 650 is 75 over X. That's not going to work either. X equals 75. Nope, that's the opposite. D is the correct answer, 650 over 75. Okay. And it works all ways. So if we needed to figure out, I know we're not doing it, but I just want to show you if they're, well, let me just solve it just because I want to put a value there. 650 divided by 75. Ugh, it's a terrible number. In this case, it's 8.7. I know that's an ugly number, but whatever. So what would be the case? Oh, I don't want to do that. 75. What if they give you, because you understand if you have the top number and then any of the 2 bottom numbers, you're just dividing. But what happens if you've got rate and time and you need to find distance? Okay, they're right next to each other. So if they're next to each other, then you multiply them, and that's going to give you D. Okay. So just learning how to use that triangle, I feel sometimes is a little easier when you're missing values than the D equals RT, because you're going to have to manipulate that around. This one, you just fill in the triangle with whatever 2 values you have, and then whether you need to multiply or divide, that'll find you your answer. Okay. All right. Last page is always the answer choices. So there we go. Got it in just under an hour. Okay. So all of these problems this week were sent to me by you, the viewer or listener, or however you're getting this. And I really appreciate that. That helps me out tremendously, because then I know what types of problems you need. So go ahead and keep sending me your problems, and I will take, sometimes I get more than 10 problems, which is great. And I will carry those over to the next session. And if I see a lot of the same problems, then I'll put that type of problem on there so that we can get that done. You can do this by sending them to info@kathleenjasper.com. Okay. And when you do that, they get sent to me automatically. As soon as they see that it's a math problem, they shoot it right into my inbox so that I am able to accommodate you accordingly. All right. It looks like there are no more questions, which is good, I guess. Okay. And yeah. That's going to be about it. Do I have any lower grade session for other subjects? This is it's just math. It's just whatever math I get into, and it's whatever I can help everybody out. It's just a generic math session. The question was, do you have any lower grade sessions or other subjects? We're just doing math because we found that a lot of people needed the math help, and just whatever we can do to help you out for an hour a week, that's what we want to do. We're teachers helping teachers, and we know what the struggle is like. So my goal is to just get you to the point of passing these tests. So send in your problems, and just know, I may not show you the the way that your math teacher, like if you go to your math teacher and you ask them how to do these problems, they're going to show you a different way sometimes, just because they're not used to what it's like to take a test. With the test, you got multiple choice answers you can use to kind of find the right answer, and you can do all these different tips and tricks. So all of our sessions are recorded, and you can go back into our YouTube channel and you can find all the weekly sessions in the playlist feature, and each one has a link for the 10 problems. So if you're looking for practice problems to do, go back a year and a half, however long I've been doing this, and you can just print out practice problems. So that's another resource for you to have. Otherwise, check out our website, KathleenJasper.com, YouTube, Facebook, Instagram, Twitter, all the major socials. That's where we are if you need to get a hold of us, if you need any help. And that's going to be it. We're in the month of May already. Can you believe it? Graduation coming up for some people, another month to go for others. Make sure that you're getting all your testing out of the way, or getting everything set up, so that when school ends, you take your tests and then you have your summer, or you have your summer to study, because don't wait for that June 30 deadline. Some of you have the end of the summer. Don't wait till the last minute to get your certification exams done. Okay. If you need anything, please let me know. Otherwise, I hope you have a fantastic week, and I will see you next Tuesday. Take